Today, I want to discuss about different types of rates. That is one, average rate, instantaneous rate, initial rate, and next, rate of reaction related problems, factors influencing rate of reactions. Average rate. What is the average rate? Rate measured over a period of time interval, that is called average rate. Otherwise, this can be written as the change in concentration with respect to reactant, also with respect to product also. That's why I am writing reactant or product. The change in concentration measured over a period of time interval, that is called average rate. How to get this average rate? Mean it is obtained by slope of a line joining two points along the curve. That is called average rate. For our better understanding purpose, a graph is drawn like this. This is a concentration, square bracket indicating concentration, and this is a time. Now, this is a graph with respect to reactant concentration with time decreases like this. So now I am drawing, this is a 2, 4, 6, 8, 10. This is a concentration in molarity, M. Time will be taken here 5 and here 10 and here 15 and here 20 in time in seconds. So now this is a concentration point with respect to time. Now I am joining any 2 points. I want to join all from this initial point. This initial point to this is a final point. If I join like this, straight line, then at what concentration? Generally rate is minus delta R concentration by delta T, change in time. Its meaning, what is that? Minus R2 concentration minus R1 concentration divided by T2 minus T1. Now minus only. So now this is a initial and this is a final. Therefore, initial concentration, final concentration is for example 2 molar minus initial concentration is a 10 molar divided by initial time is starting point 0 time. So here 0 minus here, and final time is here what is they given, nearly 15. Then answer will be, that is minus 8 minus into minus, that is a plus, therefore it is a 8 in the numerator. Denominator is 15 minus 0, that is a 15. Unit is a molar, and here for example second in taken time. So this is 8 by 15, 8 by 15 m second inverse, that is the average rate. Now you can take any point. For example, I took the initial and final up to 15 seconds. Now you can take, for example, these 2 points, 8 and this is a 4. So now if you take the slope like this, then the slope is rate average is equal to minus 4 minus 8 divided by, at 8 time is a 5, then here a 5 seconds, and at 4 mean nearly 10 is it. This is molar, this is a second. Therefore it convert into how much? Numerator 4 and denominator 5, then 4 by 5 molar second inverse, that is the average rate. Second one, instantaneous rate. Instantaneous rate is a average rate measured at a particular instant or particular time. That is called instantaneous rate. Otherwise, the change in concentration measured at a particular time. The change in concentration measured at particular instant or time, that is called instantaneous rate definition. So now how to obtain this instantaneous and what is the use? We know that first I will tell how it is obtained. It is obtained by slope of line tangent to the curve. This curve drawn concentration versus time. This is a how to obtain this instantaneous rate. So what is the use of this one? Mean, first of all, we know that average rate is measured over a period of time. Measured over a period of time. Instantaneous rate it is measured at particular instant or particular time. So to control the rate of reaction or to improve the rate of reaction, to decrease the rate of reaction, or some factors we have to provide for the greater yield of the product, at what time rate what is happening, that we should know that. That's why which is better, instantaneous rate is better to know than the average rate. Therefore in the chapter rate of reaction given meaning consider rate of reaction is instantaneous rate. Rate of reaction mean we have to consider instantaneous rate in our textbook. So now we know what is the instantaneous rate, how it obtained with the graph we can draw. Now take the one graph. This is a graph. This is a concentration in molarity, time in seconds. Then this will be drawn with respect to reactant like this. Same pattern you can take here. Now here this is a 2, 4, 6, 8, 10 molar. Then here 5, here 10, and here 15, and next 20 and 25 like this. Now I am taking this here 1.0 point and here at 5 seconds, and at the 10 and at 15 and at 20. Now I want to know the rate at any one particular time. For example, I want to know the rate at, this is called maybe at 12 minutes. At this 12 seconds, this is. Therefore, to know at this time rate meaning, we have to draw a tangent. That tangent is drawn like this. That should be touch to only which one? This yellow dot. Like this. Now this is a tangent. Now this line length you can extend at any length. You can extend up to this one, or you can extend up to this one. This depends because value will not change in the instantaneous rate, because when concentration increase time also increase, therefore overall rate will be remain same. So according to this blue line, I will take this is a which one? Concentration 6, it means y2 minus y1. So this is a like this taken. So slope is equal to what is that? Y2 minus y1 by x2 minus x1. That is nothing more, right? Instantaneous rate is expressed as minus d r concentration by dt. Average rate is mentioned as minus delta R concentration by dt. Now keep in mind, small d meaning a small change in the reactant concentration or product concentration. That's why small d is there mean instantaneous. Delta is there mean that is average. So now I am using the instantaneous rate. So now rate instantaneous given as limit delta t approaches to which one? 0, but not 0, that equal to minus d or concentration by dt. So according to this calculus, meaning what is it? The change in concentration when limit delta t approaches to 0, that is called instantaneous rate. So therefore, now R, that is instantaneous rate, is equal to minus initial and final. So 6 is initial and now 2 is the final. Therefore 2 minus 6, this is in molarity, and denominator time at 6 time is a 5, at 2 time is a nearly 20. Therefore 20 second minus 5 seconds, then we will get here, this is a 3 molar and this is a 15 molar. 3 ones are 3 fives are, therefore 1 by 5, this is sorry second, this is second, therefore molar second inverse. This is a instantaneous rate, otherwise this is a 0.2 molar second inverse. At which time this is? At 12 seconds. Like this we can calculate the instantaneous rate. So keep in mind, rate of reaction, we have to consider instantaneous rate. Now with respect to product, this instantaneous rate instantaneous is equal to plus d product concentration by dt. This is with respect to product. With respect to reactant, this is. With respect to product, this is. Now, initial rate. So what is the initial rate? Initial rate is instantaneous rate measured at reactants are mixed. That is, time is equal to 0 time. That is called initial rate. Now keep in mind, instantaneous rate is measured at a particular instant. So initial rate, what is that? It is the instantaneous rate measured at time equal to 0 time. It means starting time only, measured at the reaction starting time. That is called reaction starting time. It means that is a 0 time. So what is the overall difference between the average instantaneous and initial rate? Average rate is measured over a period of time. Instantaneous rate difference is what is that? Measured at particular instant or particular time. Initial rate meaning what is that? It is an instantaneous rate measured at starting time. So what is the use of this one meaning? For example, a reaction perform reactant to product. This is called forward reaction. Product convert into reactant, that is called backward reaction. So net rate is equal to what is that? Rate forward minus rate backward. So it is difficult to calculate. Therefore, initial rate, initially R concentration will be present, product concentration will be 0, and after some time R concentration minus X, then here X. Then after t equal to 0 time, t equal to some t. Instantaneous rate, because initial rate is an instantaneous rate. So initial rate is obtained by slope of line tangent to the curve at which time? T equal to 0 time. Now if I draw a graph, this is the graph, then this will be decreased with the time, Now I have to draw this one. These are the from some particular points considered like this. This is a which one? Initial point. So now I have to draw this one at this first point. Otherwise, for clear understanding, somewhat little change like this. So now I have, this is the initial point, next point, next point, next point. So I have to draw the instantaneous rate mean or the tangent. Tangent mean it touched the any one of the point, but here compulsory initial point only. So like this it touch. So this is called initial rate. Now this is a initial concentration, this is a final concentration. So initial time is a 0 and this is some time here. For example, this is a 10 seconds, 20 seconds and 30 seconds. Here 2 concentration, here 4 concentration and here 6 concentration, here 8 concentration. Therefore, now we will get the initial rate or initial rate is equal to minus final is a 2, initial is a 8 divided by 10 minus 0, that is called uh, that is 6 by 10, then 2 3s are 2 5s are, this is 3 by 5 molar second inverse because taken here concentration on the y-axis and time will be in seconds on the x-axis. So like this we can calculate. Here product not formed. In case we draw this one for product. So according to that, so this will be a reactant, this will be the product. Then what will happen? We have to draw, this is a graph at this point tangent. So this is called initial time. This is 0 time and this is a concentration. But actually minus dp concentration by dt initial rate is equal to product not at all formed at t equal to 0 time. Product not at all formed. Then what we can write here? A 0. Then this is called change in product concentration. Then this is the final, this is the initial. Final, for example 2, then 2 minus 0, and here time is initial, what is that? This is a final time, for example 5, then this is a 5 minus 0, therefore 2 by 5 in molar second inverse. Like this also it is calculated. So easy to calculate in the proper way for initial rate. This is useful for other parameter to find out in our chemical kinetics. For example, order of reaction also. Therefore, this is useful. So, what is the useful of this initial rate? To find the other parameter which are related to this chemical kinetics. Example, order of reaction denoted with this one. So, order of reaction to find out what is required, initial rate required. So, overall, I am drawing one graph all together. This is concentration in molarity, time in seconds. Therefore, now this is a graph with respect to reactant. Then this is a point. This is a one point. This is a one point. These 2 point joining meaning this is called average rate. Rate average. Now at any particular instant, if you draw a tangent, Then this is called rate instantaneous. Next, if you draw at this particular time like this line, this is called the initial rate initial. This is with respect to reactant. So concentration like this increase, time like this increase, together, all together in one place. Now with respect to product, so this can be drawn like this. Then now we have, this is a 1 point, this is a 1 point, this is a 1 point, this is a 1 point. So joining any 2 point, for example, I am joining these 2 points. Therefore, this is called rate average. Otherwise, I will join these 2 points. This also rate average. Now, instantaneous rate means touching at this point, for example, like this it touch. This is called rate instantaneous. Next, this one line touch at the initial concentration, that is called, at this point it is touching, this is called rate initial. Altogether, this is a concentration on y-axis, time on x-axis. This is a graph which is related to product. Now this is a product related. So now we know what is the average, instantaneous and initial rate. This is one equation, N2O5 decomposed to give N2O4 plus O2. Now according to this one, these are 2 moles, this is a 2 mole, this is a 1 mole. Then what I can say here, rate of formation of O2 is how many times of the N2O5? Now I will write here rate of consumption or disappearance. Consumption. Another one is the same N2O4 formation is therefore rate of formation. Consumption of which one? N2O5. This is formation of N2O4. Rate of formation of O2 is, observe here, this is a 2-time forming, this is a 1-time form, meaning a half-time form this is. Therefore, with respect to rate of formation of N2O4, it is how much? Half of the rate of formation of N2O4. And rate of consumption of N2O5, this is also how much? Half of this. So it is rate of formation of O2 is a half time of the rate of consumption of N2O5, and rate of formation of O2 is a half time of the rate of formation of N2O4. Now consider, always we contract this statement. Now 2 or 3 reactant, if more than 3-4 reactant is there, always with respect to one reactant or one product, these many statement form in like this. 4-5 reactant and 4-5 products are there, mean these are many times we have to write, therefore it is difficult. Therefore in general this is justified as, now we know that minus d N2O5 instantaneous rate by dt is equal to plus d N2O5 N2O4 concentration by dt, this equal to d O2 concentration by dt. this is a rate expression. Now, according to this, rate of formation of O2 is how much? Half of the rate of consumption of N2O5. Now, middle one N2O4 by dt, forget. Then how much it is? A half. 1 by 2, this is nothing but 1 by 2. So, now these two compare. Then rate of O2 is a half of the N2O5. Similarly, now we can compare the rate of O2 with the N2O4. That is also which one? Half of the which one? N2O4 rate. This is in generalized form. These two, and here nothing is there, mean 1. These are stoichiometric coefficients of the reactant. Here 2, here 2, here 1. Therefore, these are stoichiometric coefficient. So in general form, A moles of A, B moles of B gives rise to C moles of C and D moles of D. Then what is the rate expression? According to that, minus d A concentration by dt is equal to minus d B concentration by dt is equal to d C concentration by dt is equal to d concentration by dt. Product is given positive, reactant is a negative. Now, what are the stoichiometric coefficient here? A, B, C, and D. So, here A, here B, here C, and here D. So, this is a in general expression. I am taking one example, that is N2 plus 3H2 gives rise to 2NH3. This can be written as minus dN2 concentration by dt. Denominator here stoichiometric equation, nothing is there, mean 1, and is equal to minus dH2 concentration by dt. Here denominator is 3 is equal to dNH3 concentration by dt. Now, for example, in question they given rate with respect to nitrogen is 1.5 into 10 power minus 3 molarity second inverse. Then what is the rate of formation of NH3? What is the rate of formation NH3? Then we can calculate the rate and in Haber process. So they give an equation here, the above equation, that is N2 plus 3H2 gives rise to 2NH3. Here important point you have to remember, reaction they must given in the question. Why? Meaning this equation I can also write. Now I am writing the answer. This equation also I can write 1 by 2 N2 plus 3 by 2 H2 gives rise to 1 NH3. Product same, reactant same. Stoichiometric coefficients are changed. When stoichiometric coefficients are changed, then I can write this as minus n dn2 by 1 by 2. So 1 by 2 here and dt. That equal to minus dH2 concentration. This can be written as 3 by 2 and dt is equal to dNH3 concentration by dt. But actually which one? This one also takes place. Then both expressions are with stoichiometric equations are changed. Therefore, equation must be given in the question. So according to this equation, this is a expression. Now this can be solved as, now, minus dN2 concentration by dt, and they asked in the question is, and dNH3 by dt stoichiometric quotient 2. So this value they mention how much, 1.5 into 10 power minus 3 molarity second inverse is equal to, this 2 will be multiplied here, therefore multiply with the 2 is equal to dNH3 by dt. Then 15 into 2, how much, 30 means 3.0 into 10 power minus 3 molarity second inverse, that equal to dNH3 concentration by dt. This is the answer with respect to which one? Ammonia. In case they want to calculate hydrogen, then what is the answer? Minus d N2 concentration by dt is equal to minus d H2 concentration by 3 dt. Then this value we know, 1.5 into 10 power minus 3 molarity second inverse, then these 3 multiply here, then d H2 concentration by dt, then this is 4.5 into 10 power minus 3 molarity second inverse is equal minus dH2 concentration by dt. So based on this we have to know one thing here. What is that? Rate of reaction depends on stoichiometric coefficients. Keep in mind, rate of reaction depend on stoichiometric coefficient, but rate with respect to a substance do not depend on stoichiometric coefficient. That I will prove with this same problem. I told you that minus dN2 concentration by dt is equal to 1.5 into 10 power minus 3 molarity second inverse. This is with respect to, now I am writing N2 plus 3H2 gives rise to 2NH3. Another equation is 1 by 2 N2 plus 3 by 2 H2 gives rise to NH3. Another equation 1 by 3 N2 plus H2 3 by 3 is 1 and gives rise to, this is 2 by 3 NH3. Different equation with same equation with a different stoichiometric coefficient. So now I want to calculate minus dH2 concentration by dt. This is with respect to substance, no stoichiometric coefficients are required. So for example, here different stoichiometric coefficients are present. Here 3 is there, here 3 by 2 is there, here 1 is there. So same answer will come or not, we'll check now. Because rate is depends on stoichiometric coefficient, rate will be changed with the stoichiometric coefficient. If rate of a substance do not depend on the stoichiometric coefficient, mean all reaction respective answer should come the same. So now I am writing here minus dN2 concentration by dt is equal to minus here dH2 concentration by dt, this is 3. So already we got this answer in the previous one. How much is it? 4.5 into 10 power minus 3 molarity second unit, because this value is 1.5 into 10 power minus 3. This 3 will be multiplied here, then 3, and is equal to dH2 minus here concentration by dt. Therefore this value is 4.5 into 10 power minus 3 molarity second inverse. Then with respect to this, now minus d with respect to this equation, dN2 concentration by dt, and here denominator 1 by 2 means 2 goes numerator, then is equal to minus dH2 concentration by dt. 3 by 2 means 3 here, 2 goes numerator. So this value is known. So 2 only, this is 1.5 into 10 power minus 3, and this is multiply here 3 numerator and 2 denominator. Therefore 2 is equal to minus dH2 concentration by dt. Now this 2 cancel, then 1.5 into 3, that is minus dH2 concentration by dt is equal to 4.5 into 10 power minus 3 m second inverse. Now you observe here this value same for both equation. With respect to this equation is same 4.5, with respect to this equation also 4.5. Now we'll check with respect to this equation. Now this can be written as minus dN2 concentration by dt. This 1 by 3 means 1 here 3 numerator is equal to minus dH2 concentration by dt. Then this can be written as 3 and this value is 1.5 into 10 power minus 3. This value we know 1.5 into 10 power minus 3 molarity second inverse. So minus dH2 concentration by dt. So now answer again same, how much? 4.5 into 10 power minus 3 molarity second inverse minus dH2 concentration by dt. Now you observe this answer, this answer, this answer is same. Therefore, rate with respect to substance do not depend on any stoichiometric coefficient, but rate of reaction depend on stoichiometric coefficients. Now the question, 2A gives rise to 3B in gaseous form. This reaction, pressure changes from 2 atm to 1.5 atm in 10 seconds. Calculate one rate of reaction in atmosphere second inverse. Second one, mole per liter second inverse, means molarity second inverse. And third one question is pressure of B at the same time interval. Now answer. In this answer, 2A gives rise to 3B. This is a gaseous form, gaseous form. T equal to 0 time. How much pressure? 2 atm. Mean product not formed dash. T equal to 10 seconds. It is reduced to 1.5. Then how much here form? Some extra form. So we are not calculating with respect to the product, whatever the product form. Now we want with respect to the reactant. Now observe. Actually, what is the formula for this? Minus D pressure of A by dt. With respect to substance, stoichiometric coefficient not required. Therefore, minus pressure final minus pressure initial by time final minus time initial. Then what is the formula for this? Minus final is 1.5 atm minus 2 atm divided by final time is at 10 seconds minus 0 second initial. Then what answer you will get here? 0.5 we will get. Therefore 0.5 atm by 10 seconds. Therefore, our answer should be 0.05 atm second inverse. This is with respect to substance. Now, rate of reaction. Rate of reaction means what? That depends on the stoichiometric coefficient. Therefore, now this is rate with respect to A. Now, rate of reaction. How to calculate this rate of reaction? Minus d pressure of A by dt. What is the stoichiometric coefficient? 2. So now you observe that this value is how much? This we can say 0.5 atm by 10 seconds, and 2 here 2, therefore 2. Otherwise you can write like this also, 0.05 atm second inverse by directly 2 also you can write. This value already, this one by 2. Then what happened, this is, I can write this is 1 minute. I'm writing the answer here, 0.5 by 2 into 10. Then this can be written as 0.5 by 20. Then this can be point forget, then it can end 5 into 10 power minus 1 by 25. 1s are 5, 4s are. Then this is called 1.1 by 4, or 1 by 4 means 0.25 into 10 power minus 1, that equal to, this can be written as 0.025. 0.025. Otherwise, simply it can be written as 1 by 40 atmosphere second inverse. This is the answer, atmosphere second inverse. This is a rate of reaction. Rate of reaction is 1 by 40 atmosphere second inverse, otherwise 0.025 atmosphere second inverse. One answer completed. Then what is the second answer? Second question answer is molarity, mean mole per second, mole per liter second inverse. So that is mole liter inverse second inverse. Like this we have to calculate the rate. So we know that PV is equal to nRT, P is equal to N by V RT, then P is equal to CRT, delta P is equal to delta CRT. So now we have rate with respect to which one? Pressure. So now delta C is equal to delta P by RT. So rate with respect to pressure is how much now? Now we are calculating moles per liter, delta C. Then delta P, how much we got rate? 1 by 40. What is the unit? ATM second inverse. Denominator, what is that? R. R value will be taken as 1 by 12. 12 goes numerator. In, what is the unit? Liter. 1 minute space not sufficient here. So I will take, this is rate is equal to, with respect to pressure, what is it? 1 by 40 atm second inverse. So now with respect to concentration, then what is that? Delta P by RT. So this is 1 by 40 ATM second inverse by R. R is equal to 1 by 12. 12 goes numerator. Liter, atmosphere, and Kelvin inverse, mole inverse. This is R value. Temperature, I think not mentioned, mean that is nearly I am considering the 27 degrees Celsius mean 300 Kelvin. So you note down in the question is at 27 degrees Celsius. For example, considering I maybe forgot in the question 27 degree Celsius. Degree Celsius come to Kelvin 300 Kelvin. Now this can be cancelled as now this is 100 forget 3 4s are 12. 4 4 cancel. So denominator what is there? 1 0 here 2 0. 10 power 3 is there. So when goes numerator that is 10 power minus 3. ATM cancel and Kelvin inverse Kelvin cancel. What is left here? Liter mole inverse. Mole inverse goes numerator mole. Liter goes numerator liter inverse. Second inverse numerator only there. This is so. This is rate of reaction in with respect to concentration. Now another one question is what is the pressure? So we know that rate with respect to A is equal to what is the rate with respect to A? We know that our rate of reaction, rate of reaction is 1 by 40 ATM second inverse. So this can be represented as minus dPA by dt. Minus dPA by dt. Here what is that? 2. That equal to plus dPB by 3 dt. So this value is 1 by 40. This value is 1 by 40 ATM and second inverse. Then this 3 will be multiplied, then 3 multiplied, and dt later we can multiply dPB by dt. Then this is called 1 by 40 into 3 ATM second inverse. Then multiply this dt is equal to dPB. This time interval mentioned in the question is 10 seconds. Therefore, 1 by 40 3 into ATM second inverse into 10 seconds is equal to dPB. Then this second inverse second cancel. This 0 this is cancel. Then 3 by 4. Therefore, answer is dPB is equal to 3 by 4 ATM, that is nothing but 0.75 ATM at 10-second time interval pressure of B, that is the pressure of B is equal to 0.75 ATM. Factors influencing rate of reaction. One is nature of reactant or product also. How it means I will explain the next. Concentration of reactant, temperature, catalyst, intensity of light, pH. Generally for acid-base reaction, pH also affect the rate of reaction. So the detailed discussion of these all factors I will discuss in the next video.